A-Level Maths, Pure Mathematics 1, Trigonometry, some basic trig identities. Some useful trig identities. Suppose we have a right-angled triangle with an angle theta, and we label the sides H for the hypotenuse, A for the adjacent side, and O for the opposite side. Then the sine of theta is the opposite over the hypotenuse, O over H. The cosine of theta is the adjacent over the hypotenuse, A over H, and tan theta is the opposite over the adjacent, O over A. Now, from Pythagoras' theorem, we have O squared plus A squared equals H squared. If we divide all the way through by H squared, we get O squared over H squared plus A squared over H squared equals H squared over H squared. Now, O squared over H squared is O over H squared. A squared over H squared is A over H all squared. And H squared over H squared is just 1. So we've got O over H squared is the sine of the angle theta squared. A over H all squared is the cosine of the angle all squared. And that's equal to 1. And we can write that for short, sine squared theta plus cos squared theta equals 1. Now that's the first of our identities. If we start again, we've got sine theta over cosine theta is equal to O over H all over A over H. In other words, O over H divided by A over H. Well, if we're dividing fractions, we invert the second one and make it multiply. So this is O over H times H over A. Now the h's cancel, and so we're left with O over A, which is equal to tan theta. And so we have the second result, sine theta divided by cosine theta is equal to the tangent of theta. Now if we look at the triangle again, the third angle in the triangle is 90 minus theta, because the angles add up to 180. And for the angle 90 minus theta, we have A is now the opposite side, and O is the adjacent side. So, the sine of 90 minus theta is A over H, which is the cosine of theta. The cosine of 90 minus theta is O over H, which is the sine of theta. And so we have the results. The sine of 90 minus theta is equal to the cosine of theta, and the cosine of 90 minus theta is equal to the sine of theta. Now it's important that you learn these four results. They can be very useful in solving problems. Now let's see how we can use these four results to solve a problem. In example 1, we want to prove that 1 minus cos squared theta over 1 plus sine theta is equal to sine theta. Well, to do this, we must start with one side and prove that it's equal to the other side. So let's start with the left-hand side, which is 1 minus cos squared theta over 1 plus sine theta. And remember, cos squared theta is equal to 1 minus sine squared theta, because cos squared theta plus sine squared theta is equal to 1. So we can change the cos squared theta on the top into 1 minus sine squared theta. So that gives us the left-hand side is equal to 1, take away 1 minus sine squared theta over 1 plus sine theta. Now, on the top, 1 minus sine squared theta factorizes. It's the difference of two squareds, and so now we've got 1 take away 1 minus sine theta into 1 plus sine theta all over 1 plus sine theta. Now we've got 1 plus sine theta on the top and on the bottom, and so they can cancel. So that's 1, take away minus sine theta. So that's 1 minus 1 plus sine theta, which is equal to sine theta, which is the right-hand side. Let's have a look at another example. This time we're going to prove the cosine of theta over 1 plus sine theta is equal to 1 over the cosine of theta minus tan theta. Well, let's start with the left-hand side. Cosine of theta over 1 plus sine theta. Now we're going to multiply the top and the bottom by 1 minus sine theta. So that gives us on the top cos theta into 1 minus sine theta, and on the bottom 1 plus sine theta into 1 minus sine theta. And we can expand the brackets on the bottom. And that gives us cosine theta into 1 minus sine theta all over 1 minus sine squared theta. But we have 1 minus sine squared theta is equal to cos squared theta. So altogether it's equal to cos theta into 1 minus sine theta over cos squared theta. And we can cancel a cosine top and bottom. And that leaves us with 1 minus sine theta all over cosine theta. Or we can write that 1 over cosine theta minus sine theta over cosine theta. But we know sine theta over cosine theta is equal to tan theta. And so we've got 1 over cosine theta minus tan theta, which is the right-hand side. In example 3, we want to prove tan squared theta plus 1 is equal to 1 over cosine squared theta. Well, if we start with the left-hand side, we have tan squared theta plus 1, and we can use the fact that tan theta is sine theta over cosine theta. So the left-hand side is sine theta over cosine theta all squared plus 1, which is equal to sine squared theta over cos squared theta plus 1. And if we place it over a common denominator, that's sine squared theta plus cos squared theta all over cos squared theta. But sine squared theta plus cos squared theta is equal to 1. So we've got 1 over cos squared theta. And that's the right-hand side. Now in example 4, we want to prove that 1 minus sine theta over cosine theta is equal to cosine theta over 1 plus cos theta. And to prove this, we're going to start with the left-hand side. Now that's equal to 1 minus sine theta over cosine theta. And we can multiply the top and the bottom by 1 plus sine theta. So that gives us 1 minus sine theta into 1 plus sine theta over cos theta into 1 plus sine theta. Now the top is the difference of two squareds, and so we can simplify it, and it becomes 1 minus sine squared theta, and the bottom is still cos theta into 1 plus sine theta. But 1 minus sine squared theta is cos squared theta, so the top becomes cos squared theta, and the bottom is still cos theta into 1 plus sine theta. Now we've got a cos theta on the top and a cos theta on the bottom, and so they cancel, and that leaves cosine theta over 1 plus sine theta, which is the right-hand side. So we have solved the problem.